Hello everybody and welcome back to another video. Today I'm watching Why Humanity Will Never Leave the Solar System by Kurzgesagt. Quick thing that I have to say before I get to the reaction part. I've already watched this video, but my microphone was turned off so it didn't record my voice. So yeah, I'm doing this again.
You will never leave the solar
system. So
system.
yeah, I already know exactly what this video is about.
Today will, and maybe no human ever. Locked in by an
but I've put too much effort already
to
just scrap the whole thing.
Like us.
So I'm just rewatching it.
Not just us. There may be millions of alien civilizations in the universe.
Very well could be possible.
Ever able to venture into deep space in a meaningful way. Okay, but how can this be? We've made countless videos imagining how the exploration of the galaxy and beyond should just be a question of time, sort of mandatory for civilizations at a certain point. But there's a catch. We're pushing up against fundamental physics. What is this barrier made of dust?
There's a certain point where you can't go any further.
So hard to overcome? You don't understand how large space is. We don't either.
It's
conceptualizing the
too difficult for the human brain to comprehend.
Brains that evolved to understand distances like right here and over the next hill. Space is so absurdly huge that we just check out and just hear very far. Very far and a million times very far feels the same, but it's not. To help our brains, let's start with what makes us cross distances: speed. The fastest a human ever traveled in space were astronauts at 40,000 kilometers an hour, returning from the moon in 1969.
Which is nothing in the grand scheme
Not
of
bad,
things.
But way too slow. The fastest thing humans have ever built by far is the Parker Solar Probe, which at this moment uses a physics cheat code hurling around the gravity well of Venus, accelerating to get closer to the Sun. After 7 years of doing this, the probe is shooting through space at a breathtaking 635,000 kilometers an hour.
Which is
Fast
crazy
enough
to
go around
imagine.
the world in 4 minutes, or
But
to
still
cover the
too
distance
slow.
from Earth to the Moon in 36. So let's pretend we had a spaceship that fast with a human crew ready to explore the universe. Current rockets would need 7 to 10 months to reach Mars, but our new spaceship covers the distance in just 2 weeks. Pretty good.
Mars is not that far
Pluto,
compared to
which
other
will reach
things.
after about a year. Okay, much longer, but still okay. It only takes 2 more years to pass the heliopause, and 1 more to pass Voyager 2, which traveled over 50 years to get this far. Great. The next stop is the end of the Oort cloud, the true edge of the solar system where open space begins. We reach it in 2,500 years.
Yeah, that's way too slow.
Not only did we travel for the amount of time it took to get from the founding of the Roman Republic to the present day, there's nothing out here. This is the invisible barrier, the barrier of nothingness that might trap us in the solar system forever. Space tends to be like that. There is a place that's very far away, but with human ingenuity and billions of dollars, we can get there. Then you zoom out 1 more time, and all hope leaves your body. And the problem is that we've barely started zooming out. Why don't we just go faster? Well, we don't know of
There's physical limitations to how fast you can go.
Teleport or freeze people. So no warp drive for now. But things like a propulsion system that uses nuclear fusion or antimatter powerful enough to reach a substantial fraction of the speed of light are in the realm of the physically possible.
Yeah, the speed of light goes almost 300,000 kilometers a second. That gives about a little over 1 billion kilometers per hour, which sounds like a lot, but it's still nothing in the grand scheme of things. It won't get you very far.
Ignoring the technical details and various
there's
problems
nothing faster than the speed of light.
We'll be very optimistic and make the reasonable assumption that we can get a spaceship to fly at around 20% the speed of light, which is extremely fast, 60,000 kilometers per second, 216 million kilometers per hour. Fast enough to reach the edge of the solar system in just 3.5 days and the outer edge of the Oort cloud in 8 years. Alpha
Which is
Centauri,
ridiculous.
The closest star system to our own, in 20 years. We can work with that.
Even if you were going at the actual speed of light, which I'm quite sure is impossible to achieve, it would still take you a little over 4 years. Think about that.
Centauri,
Ridiculous.
The closest star system to our own, in 20 years. We can work with that. Everything should be sorted out now, right? Well, there's only one small issue. Space hates you. The barrier of dust.
Humans were not designed for
Unfortunately,
space.
we'll run into a few obstacles on the way. Literally. Because while space is very empty, it's not actually empty. There are energetic particles, gas, dust, and things bigger than dust. As a lot of unhappy people experience every day, if you're going really fast and smash into something, you have a huge problem. And at 20% the speed of light, this is true even if the thing you're smashing into is just an atom. An individual iron atom that hits your spaceship at this speed has enough energy to carve a damage track tenths of a millimeter deep. Over time, its hull will be riddled
they'll
with microscopic
accumulate.
bullet holes, which is not great. Of course, our engineers knew this and created a shield for our ship, a sort of protective sail that absorbs or at least slows down most molecules we smash into. And while this makes the journey much safer, there are things floating around in space that are larger than atoms. Running into a single grain of dust at 20% the speed of light is like running into a grenade, causing a tiny detonation as the dust explosively evaporates, grinding away our protective shield. But you can also hit something bigger than a grain of dust, like a small rock the size of a golf ball.
Which is basically
Hitting that at 20% the speed of light releases more than
nuke.
double the energy of the nuclear bomb that was dropped over Hiroshima. We'll not even talk about anything larger. Atoms, dust, and pebbles are dangerous enough. We might have reached our natural speed limit here. Beside the fact that we don't have a good idea how we could possibly fly any faster, all of the damaging effects of hitting stuff floating around in the void get much worse fast. Having said all that, it's probably fair to assume that with enough shielding, our spaceship should be able to survive traveling through space at roughly 20% the speed of light.
But
long
how
enough
much can
to
you
get
really
to at least
add?
nearby stars in a reasonable amount of time. Only one more issue to overcome. Almost everything in space that's close is super lame. The first proper target outside the solar system is the Alpha Centauri system, which is roughly 10,000 years with our original slow, more realistic ship, but only 20 years with our super-fast fictional ship.
still a ridiculous amount of
Let's
time.
cram a few unlucky humans into a tiny box for 20 years and send them on their way and assume they somehow make it without murdering each other. 4 years.
Yeah, see, this would still take 20 years if you're going at 20% the speed of light. In those 20 years, all it takes is for one thing to malfunction or break down at any point of the journey, and the entire thing could be foobar, and it's over. 20 years is a long time. A long time for something to go wrong.
After their arrival, their message reaches Earth. People around the globe gather together and hold their breath, eager to listen to it. We arrived. Alpha Centauri and its planets are very pretty up close. Unfortunately, they're all super
not
deadly
livable,
and
not
uninhabitable.
habitable.
But we're doing extremely cool astrophysics and are learning a lot, which is pretty exciting. We're getting kind of tired of freeze-dried food and desperately need new shows to watch, though. Not
Yeah,
sure
this
what we were
would
thinking
this would really
coming
be a
here.
one-way mission.
The
Like,
thing
you're not
about
coming
space
back
is
from
that
this.
Almost all close destinations, if close means something different from what it usually means, are pretty lame. Not from a scientific perspective, of course. It would be an absolute dream to have the privilege to set foot on foreign planets and marvel at the wonders of our universe. But if 20% of the speed of light might be our speed limit, and we give humans a realistic travel time of, say, 40 years, we could reach things that are up to 8 light years away.
Which
None
is
of the targets
nothing.
remotely within this range, within a human lifetime, may be worth traveling dozens of years in a tiny box through one of the deadliest environments imaginable. Our solar system is a bit unlucky in that regard. We're in a relatively empty pocket of the galaxy. This might change in a few million years as we move through the galaxy, and
A
there
few
might
billion.
be small, localized, star-spanning civilizations.
At that point,
We discussed
humanity will
this
no
in another
longer
video.
exist.
Let's say that
Probably.
we could go much further, to any of the stars within our stellar neighborhood, a sphere about 25 light-years in diameter. 0.02% of the Milky Way, by the way. This tiny bubble is currently inhabited by 34 stars and 6 brown dwarfs. Only 3 stars in our neighborhood are similar to the Sun. But one of them is actually the Sun, and another one is Alpha Centauri A. The other stars close to us are mostly red dwarfs with planets that vary from deadly to super deadly. There are a few planets in the habitable zones of their stars where water can be liquid, but Mars is also in the habitable zone of the Sun, and
Yep.
it's really bad. Even the planets that we think look most like Earth, like GJ1061d, come with no guarantees. Imagine traveling your entire life and then arriving at a Mars. What a brutal letdown that would be. There are a few stars that would be interesting targets and may have actual habitable planets.
Really, it would make more sense to try to terraform Mars and make it a habitable planet than trying to find one somewhere out in space. The main reason is because Mars is so close to Earth. When compared to all the other options, Mars is pretty much the closest one we have. It would certainly be a lot less risky and take a lot less time than trying to go anywhere else. So, if humanity ever does make colonies in space, it's probably gonna happen on Mars rather than on one of these really far away planets, because Mars is simply way closer and much less risky. We'd only have to learn how to terraform it, which is already an incredibly difficult task and it will probably never happen, but it's still easier than the alternative. Also, this is all just about traveling to these places. This isn't even mentioning setting up a colony, which would be far more difficult.
With oceans and atmospheres that are breathable, which probably would mean that they have some form of microbial life, if not more. It would be extremely interesting and definitely worth it to check them out. But they could be dozens, if not thousands, of light years away, which means journeys of hundreds or thousands of years, even at a large fraction of the speed of light. Of course, it is maybe feasible that a future humanity that is technologically way more advanced than us and very motivated could find solutions. Maybe they've solved biological aging and a travel time of a few hundred years doesn't seem that bad to them. Maybe they could send AI spaceships with embryos or some version of that into space. They'd probably have way more advanced telescopes to make sure they don't choose star systems that are deadly and empty. But it's still hard to imagine without real science fiction technology how they could build and sustain a connected civilization. Conclusion. The longer you think about...
Yeah, I mean, simply sending messages that far away is already going to take so much time. It's just not feasible. I watched a video, I don't know if it was by Kurzgesagt or some other channel. It was about making a colony on Mars, and in that video they said that sending messages between Earth and Mars would take like 20 minutes, which that is already ridiculous and creates a lot of issues, especially in case of an emergency. But anywhere further, it could take years for messages to arrive, which... yeah, it's just not happening.
Deep space, the less it makes sense. The distances
and the
are
more
too
impossible
vast.
It is.
There's a deadly speed limit, and even if we could solve these issues, almost all destinations even remotely reachable may not be worth the trip. Space is the greatest challenge humanity will ever face. Right now, we're just not equipped or able to solve it. Rockets, computers,
probably
and even
never
nuclear
will be.
fusion reactors are hopelessly underpowered. We need technology that's overwhelmingly transformative, something as wild to us as flying to the moon would have been to a hunter-gatherer. Will we ever get there? We genuinely don't know. But it is good to remind yourself of something. There are few things that make you look dumber than predicting the future of technology. In 1903, the New York Times published an editorial, "Flying Machines Which Do Not Fly," that confidently predicted it would take humans 1 to 10 million years to achieve powered flight. 69 days later, the first successful flight happened. 66 years later, humans landed on the moon. So, we really hope this video will seem as dumb as this article in 100 years. And there's another option entirely. Maybe our thinking about all of this is just completely wrong. Maybe the future is not out there, but deep down. But we'll explore that in another video.
See, this is what I was confused about. I don't understand what the Barrow scale is, I've never heard of it. But yeah, that's going to be in a different video. Yeah, this sucked. Not the video. The video, it was great. Everything was awesome. The thing that sucked is the fact that I had to record this a second time because the first time my microphone just wasn't turned on. And it's my own fault too, because I didn't check. I just assumed it was turned on, which it wasn't. But yeah, I mean, I said everything I wanted to during the video. Again, I don't think humanity will ever go to space and settle other planets. It just doesn't seem feasible to me. But again, who knows how things will look in a couple hundred or couple thousand years, and if humanity is even going to be around at that point. None of us will be, so we'll never know. So yeah, I hope you enjoyed this video. If you did, please consider subscribing and leaving a like. If you want to see more reactions, check out this video right here. And with that, I hope I'll see you in the next video.